Hi everyone, this is Lukonde. Welcome to the lesson. Today we'll continue talking about functions and I hope everyone is doing fine. I should make this video as brief as it should be. I won't keep you here watching my video. So now we'll talk about the inverse of a function, okay? The inverse of the function, as this term suggests, it is the opposite of the actual function. It is the opposite of the actual function. If the function is defined from x to y, okay, capital X to capital Y, where x is a subset of R and y is a subset of R, these are subsets of real numbers. Every x you pick from x gives you f of x is equal to y, which is a member of capital Y, okay? So for every x you take, you expect to have an image in y, okay? So every x, a member of x, there exists f of x is equal to y, a member of y. This is the definition of a function, okay? Now, if we have to get an inverse, it means the inverse is defined from y to x, okay? The function is defined from x to y, then the inverse is defined from y to x, okay? So for every y, a member of y, there exists f of y is equal to x, a member of x, okay? So this is the definition of an inverse, okay? So the inverse of a function is the opposite of a function, of the actual function, okay? So you can see the illustration of a function for this non-empty set, okay, x, and this y is a non-empty set. We have four elements a, b, c, d, and we have four elements 1, 2, 3, 4. A goes to 1, b goes to 2, c goes to 3, d goes to 4, such that f of a is equal to 1, f of b is equal to 2, f of c is equal to 3, and f of d is equal to 4, okay? So this is a function. This function is 1 to 1. It is 1 to 1 because every element goes to one element. It's 1 to 1, 1 to 1, okay? 1 to 1. And of course, this function is bijective. It is onto, okay? This function is onto because the range consists of all the members of y, okay? The range consists of all the members of y. If the range f is equal to b, then the function is onto, okay? The range is this set within b, okay? It's the set within b, but if the range f is equal to b, then the function is onto. Otherwise, the range f is a subset of b, okay? For an into function or the injective function. So for a function to have its inverse, that function has to be 1 to 1 and onto or bijective. The function has to be 1 to 1 for it to have its inverse, okay? So functions which are 1 to 1, they have inverse, okay? So now look here. This is the function from x to y, and now this is the inverse, okay? The inverse is now we're coming from y to x. So 1 goes to a, 2 goes to b, 3 goes to c, and 4 goes to d, okay? Okay, so I wrote this, okay, which I have talked about. So I have talked about f of a is 1, look, because a goes to 1, and f of b is 2 because b goes to 2. Now the inverse of a function is denoted by f, okay? Just like you can denote a inverse as this, okay? This is a inverse, okay? When you have a, the inverse is that. So for the function, the inverse of a function is denoted by F inverse. So now since one goes to A, so F inverse of 1 is A, okay? Then F inverse of 2 is B. F inverse of 3 is C. F inverse of 4 is D, because 1 goes to A, and that's the inverse of the actual function, okay? And F inverse of 2 is B. F inverse of 3 is C. F inverse of 4 is D. While F of A is 1, okay? This is F, then this is inverse. So this is a simple illustration of the inverse of a function, okay? It is the opposite of the actual function, okay? Yes. Now, look, why should the function be 1 to 1? Okay? Why should it be 1 to 1 for it to have an inverse, okay? Look, let me illustrate this here. Talk about a relation, okay? So you have a relation, you have elements here, okay? This is a definition set, okay? This is a domain. And then this, like, let me call this A, okay? A, and this is a codomain B, and this is a function. So if this element relates to this, and this one relates to that, and this one relates to that, then this is a function, because every element in A has an image in B, okay? There is X here, and you have F of X. This is a function. But if you have a relation like this, where you have 2 elements, and you have 3 elements here, one goes to this, and the other one goes to here, you have 1 element remaining here. Now this is not, this is a function, okay? This is a function, okay? But it is not onto, okay? This function, the range F is a subset of B, where this set is B and this is A, okay? Range F is a subset of B. There is an element remaining here. Now, if you have a relation like this, you have 3 elements, then one goes here and the other one goes here. Now this set is A and this one is B. This is a this one represents a function transformation. Now this is not a function, because this element here in X has no image in B, because the definition of a function says every X, okay, a member of A, should have F of X, a member of B, okay? But this one is not a function, okay? That does not work, okay? So similarly, if you have a function relation which is injective, which is into, you have these elements, okay? This one goes to this one goes to this, and you have this one, okay? You have this one. So this is A and this is B, okay? So the function is going to this other side. Look, for every y a member of B, there should be f of y is equal to x, a member of A. Now look, this y is remaining untouched, so this is not a function from B to A, because this element has no matching in A, so this is not a function. So a function has to be it has to be onto, okay? It has to be onto, okay? It has to be onto for it to have an inverse, okay? I should revise the statement I said. The function does not need to be 1 to 1, okay, for it to have an inverse, but it has to be onto for it to have an inverse. It has to be bijective, okay? It has to be onto, okay? For a function to have an inverse, range f is supposed to be equal to b, okay? So that's the main point, okay? Functions which are not onto have no inverses, okay? It's not possible for an into function to have an inverse. It is not defined. Now, look at these examples. F of x is equal to x, f of x is equal to x minus 1, and f of x is equal to x squared, f of x is equal to 1 over x minus 1. Find the inverse of these functions. So, A, f of x is equal to x. I said a function which is equal to a function of this matter, nature rather, is called an identity function, okay? Where the input is equal to the function, okay? So, this is an identity function. So, what is the inverse? First of all, you have to make x the subject of the formula, okay? So, y is equal to f of x, okay? This is what we use, okay? Y is equal to f of x. Then, since f of x is equal to y, so y is equal to x. Now, you are making x the subject of the formula. So, x is equal to y, okay? So, x is equal to y. Then, f inverse of x is equal to what? Y, okay? Because x is the same as f inverse of what? X, okay? So first of all, the first step is to make x the subject of the formula, and then you replace this part where there is x with f inverse of x, okay? Is equal to x rather, not this, is equal to x. I made a mistake here, okay? Now, f of x is equal to x minus 1. So let y to be f of x. So y is equal to x minus 1. Now make x the subject to the formula. So when you take 1 to this side, it is going to be positive. So y plus 1 is equal to x, okay? And when you make x the subject to the formula, x is equal to y plus 1, right? So f inverse of x is equal to, where there is y, you put x, okay? F inverse of x is equal to x plus 1. F inverse of x is equal to x, okay? Now, f of x is equal to x squared. Let y be f of x. So if y is equal to x squared, then you are making x the subject of the formula. So you take the square root both sides, okay? So root y is equal to root of x squared, then this one cancels. So we have x is equal to root y. So f inverse of x is equal to root of x, okay? Root of x, not y, okay? Because you are putting x where there is y, okay? And just call this equation to be f inverse, okay? So f inverse of x is equal to root x. Similarly, f of x is equal to 1 over x minus 1. So let y to be f of x. So y is equal to y over x minus 1. You cross multiply. You're going to have y times x minus 1 is equal to 1. The point here is to make x the subject of the formula. To make x the subject of the formula, you have to divide by y, both sides. So x minus 1 is equal to 1 over y. Then you take 1 to the other side, x is equal to 1 plus 1 over y. So in place of y here, you put x. And in place of x, you put f inverse, okay? So f inverse of x is equal to 1 plus 1 over x. Okay, yeah, so that's it. This is how you solve simple questions to do with the inverse of a function. Okay, this is how we do it. Like for instance, you have like f of x is equal to let me say square root of x minus 1. Okay, now find the inverse of that. So y is equal to f of x. So y, whatever there is f of x, you put y. So for you to make x the subject of the formula, you square both sides. You square. This is x minus 1. You square. Square, square goes. This one is y squared. Then x minus 1. So x is equal to, when 1 goes to this one, becomes positive. Y squared plus 1. So now, in this place, you put f inverse of x. On y, you put x. So that's the inverse. Okay? As simple as that. Okay? God bless you.